All right, good afternoon. I am Dr. Kay Stefanik, Assistant Director of the Iowa Nutrient Research Center. I want to welcome you all to the final seminar in our Fall 2025 series, Working Towards Better Water Quality through Regional Collaborative Research. Today we have two speakers with us, Dr. Raman, Morrill Professor in the Department of Agricultural and Biosystems Engineering at Iowa State University and Director of RegenPGC. And we also have Dr. Brandon L. Schlautman, Lead Scientist, Perennial Legumes with the Land Institute and Research Theme Leader for RegenPGC. They're going to be talking about their work on their RegenPGC project. Now, before I have a few housekeeping items. First, please type any questions you have to our speakers into the chat box, and I will read them at the end of their presentation. Second, this webinar will be recorded and posted to the INRC's website along with previous seminars. So with that, the virtual floor is yours.
Dr. Stefanik, thank you very much for inviting us here. I'm really pleased to be here with my friend and colleague, Brandon Schlautman. I'm going to kick things off here, and we're going to talk over each other as we go through this. Our title was, I think we shortened it for advertising to The Valley of Death is Easier with Partners. But here's the whole title. You can all read it. And just before doing this, I thought, really, you should have just called this Misery Loves Company, Raj. But that's our title for today. And we hope to give you some ideas about what it's been like on this journey, tell you actually what the Valley of Death means. Some of you may not be familiar with that term. And talk about what we're doing to try to shepherd PGC through the perennial ground cover systems through the Valley of Death. So this project, RegenPGC, is a USDA NEFA SASCAP that was initiated back in September of 2021. So we are in year 5 of 5, and we're hoping to get a no-cost extension, and we'll see whether that happens or not. And the disclaimer here is absolutely true. We're very grateful for the support that we get from the USDA, but anything crazy that we say today is not their fault. Perennial ground cover systems, the basic idea is that you plant a cover crop one time, but you get multiple years of benefit from it, and therefore potentially far fewer field operations, or at least fewer field operations. To make that system work and not cause a yield drag, I mean, let's back up. Like, you can do this anytime you want, but and it doesn't have to be a complementary in space and time ground cover, and you will suffer tremendous yield drag. So that's fine and good for some very small fraction of farms that aren't highly yield motivated, but if you want to make a difference to water quality and soil conservation on a large scale, you have to acknowledge the reality of the pressures on the people growing those crops. So to make it work, to do this without yield drag, you have to have a ground cover that's temporally and spatially complementary to the row crop. And in general, those are present at sufficiently low densities that you're probably not harvesting them. We're primarily trying to get ecosystem services while being very low cost and low barrier to entry. That's the vision. Grazing PGCs, you can ask Brandon about it later. It has mixed results from what we've seen so far. And I'm going to turn now to Brandon and have him talk a little bit more about the PGC seasonal cycle, as it were. Brandon.
Thanks, Raj. So this is a figure that kind of just depicts what we imagine a perennial ground cover system is going to look like. If you start at the zero phase, we're going to plant the perennial ground cover potentially in the spring, but more likely in the fall, just like any other annual cover crop we might use. And it's going to grow and protect the soil over the winter, just like an annual cover crop. When we get to the spring, that's, I think, kind of the major difference between management of a perennial ground cover compared to an annual cover crop. We're typically strip tilling the fields to create what we call a crop zone, where the corn or soybeans are planted. And depending on the perennial ground cover, we also think it's pretty critical to suppress the perennial ground cover using a contact herbicide or potentially other management practices to reduce its competitiveness with the corn or soybean as they're emerging and growing as young seedlings. When we get into the summer, the management, I think, kind of goes away. We can do most of the things the same as we are with our typical corn and soybean rotations. The ground cover is growing underneath of the corn, but really not producing as much of a competitive effect once it's big and tall. Kind of like the research that you may have seen, interseeding annual cover crops into corn after V6. And then when we get to the fall, when we get to cycle 5 here, the corn and beans are senescing, the ground covers as a cool season crops really kind of coming back on. And the difference between an annual cover crop system and these perennial ground covers is that from 5, we go straight back to 1. We don't have to replant it. So this is a kind of an annual cycle, I guess.
Thank you, Brandon. So, as you might imagine, getting a perennial cover into a field can provide a wide variety of benefits. I'm not going to talk about these in detail. It's just that having something growing essentially year-round, or at least maybe the only time it's not really growing is wintertime and the early mid-season of the growing cycle of the row crop. It really potentially can provide a lot of benefits that are not present with the current annual cover cropping system that we're so used to here. So sort of the large scale, our overarching goal of this project is to try to perennialize working lands at scale, thereby improving soil conservation and water quality, while maintaining or increasing profitability, enhancing biomass production, and improving overall system resilience. Yeah, why not reach for the stars? But as it turns out, getting to scale is very non-trivial for multiple reasons that are frankly easily forgotten in our excitement as researchers. I want to just throw some of those down here for you. So how simple actually is this new process compared to business as usual? And by the way, I'm for a moment not talking so much about perennial ground cover only, but about any novel approach for conservation. What's the reliability in terms of yield reliability for these systems? Obviously, for some edge of field practices, it doesn't have any impact on your yield. But for in-field practices like annual cover cropping or perennial ground cover systems, there is a potential yield implication there. What are the management and labor needs of this new system versus our business as usual practices? How about infrastructure? Is equipment that we need for this novel approach? Do I have it? Does my agronomist or neighbor or co-op have experience with the system? Who do I call if things don't go the way they're supposed to? How does this fit into existing policy frameworks? What does this mean for my insurability? And again, for a system like perennial ground cover where you're producing the same grains that you normally would, this isn't so much of an issue. But for other systems, Brandon has been centrally involved in Kernza, for example. What's the market for the new products from this novel system? So I want to tell you that the co-PDs on this project wrestle with these challenges, and that having partners from a wide range of institution types, and you can see those listed there on the right side of the screen. I'm not going to insult you by reading this to you, but we have, I think, notably a combination of public universities and large agricultural companies and how do I describe the Land Institute? Not-for-profit, publicly minded institutions. So I think it's a tremendous combination of people that we have on this grant, and we've been trying to work these issues. We also have a very engaged stakeholder advisory board listed here, reflecting a range, again, of different entities. We built a structure for this project that I'm really not going to focus on very much, but we sort of intellectually said there are sort of 5 main sorts of things that we're working on. You can see them here. And then we have these cross-cutting themes, each of whom has a leader. So Brandon is our research theme leader. Ken Moore is our education theme leader. He's also the godfather of this perennial ground cover vision here at Iowa State anyway. Dan Anderson is our extension theme leader, and Sarah Lira is our commercialization theme leader. So I'm going to defer to Brandon again for a minute about examples of the kinds of research that we're doing.
This is a quick figure that the Land Institute where I work sort of has a mission and a vision to figure out how to incorporate two things, perenniality and plant diversity, into row crop agriculture. And I think those two, I guess, functional traits are common in prairies and other natural ecosystems. We see them as being important and we want to mimic them in some ways. But when we think about the row cropping systems that we want to develop and how they differ from natural systems, we might sometimes imagine that in a prairie, all the plants are getting along really well. They fill their niches kind of perfectly. But the reality is that we have competitive interactions that are really common in natural system. And in this figure, that's what the red lines are showing, that maybe there's some source of competition above the ground. There's one red figure that shows above and another below the ground. And I think the general concept, the science that we're trying to do in this project is to figure out how do we design a perennial cover crop system, choosing the right species of ground covers, figuring out the right varieties of corn, figuring out the management practices that allow us to maximize the green interactions, which might be considered complementary interactions, while reducing as much as possible the competitive interactions, the red interactions, and therefore getting to the point where we can have a cropping system that yields similar, if not better, than the existing cropping systems we're trying to replace, and at the same time accomplishes the ecological outcomes that Raj has been talking about so far.
Thank you, Brandon. So we have some very specific targeted impacts, the first being to provide a low barrier to entry way of perennializing working lands, ideally sufficiently low in cost to farmers that it would be subsidy independent, potentially greatly increasing the fraction of production systems that are using regenerative agricultural practices. Maybe a meta impact is to create a framework for the development of these sorts of systems. And then a critical educational impact is to create a cadre of K-12 educators who can deliver crop environment system relevant STEM education to their students. And I have to say this is a shining star in what we're doing. It's not a focus of our conversation today, but Ken Moore leads our education effort. Maureen Griffin is really doing a lot of that organization of our research experience for teachers, research experience for undergraduates. Uniquely with the REU program that Maureen does, she's been bringing in students who are studying to teach K-12. That's a different group of students than I normally interacted with in the years that I was doing REU programs, and I think it's a tremendous opportunity to show the relevance of science. It's not something. I think that's something that we have struggled to do at the university, is to communicate that, especially to students who aren't in our science-focused degree programs, and that's a bright spot. And we have a phenomenal cohort of systems-oriented graduate students working on different aspects of perennial ground cover systems. So, I've said this. We have some outstanding educational programs. One of the things that Brandon really forced us to do, suggested that we do, is to sort of restart a cafe that we had been doing before we got the funding, sort of in the years that we were wandering in the desert trying to figure out how we were going to organize ourselves to get a large grant. We were doing this informal cafe periodically to talk about what we were thinking, how we were going to move things forward. And once we had the project, I think it took a year or two, but we reinstated the cafe, and that's really been a vibrant place for conversation and argument, because I think good research projects, you can't expect everybody to see these problems and their possible solutions the same way. And I really like the kind of conversations and arguments that we're having in those events. We've had excellent extension, commercialization, outreach, both face-to-face and virtual. And we've secured some additional funds, some of which have gone away with changes in administration, but we won't focus on that today. Let's talk about some of the key learnings from the first 4 years, and we're going to make our way to explaining the valley of death here. First, we've shown that some of these wonderful ecosystem services can be experienced at zero yield drag. And I'm being honest and showing you one here. Here's 2024 in what I would call a non-conforming system. In other words, when we operated this particular experiment, we didn't do the best practice. We had to make a call between skipping a year or doing it wrong. We decided to do it wrong. And here, if you see the 125 versus 189, that's the kind of yield drag that you can get in a perennial ground cover system where that ground cover is bright green and thriving through the first 6 or 7 weeks of corn post-emergence. 2025, because that ground cover had a year to grow in, and because we suppressed it and did a better job of defining the crop growth zone that Brandon referred to, those yields are much more acceptable, 207 in the RHB radix hybrid bulbosa perennial ground cover compared to 193. I would note, interestingly, the soybean in 2024 got the same treatment, and soybean did something that we've seen it do a couple of other times, which is it shrugged the competition off. Interesting to me. And then in 2025, the soybean did better in the RHB. Hey, are you ready to run out and put RHB in all your soybean fields? Take a breath, because it was a really wet year, and Dan and I wonder if some of the nice benefit there, the improvement in the RHB compared to the control, is reflecting a little bit of, in really wet years, you'll get some more bang for your buck out of this. But the point is that we've seen some of these things, and in fact, this isn't new. I'm going to turn this to Brandon for a second.
I had thrown this slide in here when Raj was asking me what to do. This is kind of the inspiration that got me working on. When I was in grad school at Wisconsin, there was a professor named Ken Albrecht that was forage agronomist there using currant clover as a potential perennial ground cover. And this is some of the data that he showed, and having the currant clover ground cover in his system reduced the runoff by 90%, reduced the amount of soil loss from the system by almost 80%, and reduced the P and nitrogen loss by 80%. And that's similar to the research that Amy Khalid has been doing now in the RegenPGC project, and kind of demonstrates the potential outcomes that we could achieve if we can get the genetics and the management practices and everything working in the system. So, yeah.
Thanks, Brandon. So getting to scale is tough. Many of our on-farm trials have struggled. We managed to start our project at the tail end of a essentially historical drought, 50-year kind of drought here. We attempted nearly 60 PGC on-farm trials since the inception of our project, totaling 180 acres. And I'm excluding some very large PGC trials that Brandon has been involved in, but not with his RegenPGC hat on, or at least that we didn't fund. And most of these trials have been what we would call conforming trials. These are these trials where you actually are implementing what we understand to be the best management practices. We had 75% of those trials that basically failed, with the vast majority a simple failure to establish. That is the ground cover, especially the Kentucky bluegrass, which is the other primary ground cover that we have been using, not growing due to dry conditions. We had a handful heartbreaking ones where the ground cover, either Kentucky bluegrass or RHB, did establish and was subsequently sprayed and killed. In the remaining in the remaining 25% of those field trials, 2/3 had yields, grain yields, 90% of the control or better. Again, we believe that this stuff can be done. It's deeply frustrating. I don't really come here proudly reporting those numbers to you, but tell you what, failure is a wonderful way to accelerate learning. And because of these experiences, we really in the last 9 months or so have articulated the following 6 primary risk factors for perennial ground cover systems. The first is ground cover establishment, and I think you understand why I say that. The second is ground cover suppression. Fun fact, when we started this project, if you had asked me what stands between us and getting this system ready to go to lots of people, I would probably only have said ground cover suppression and maybe policy. But yeah, as I said, failure is a way to learn. Crop zone management impacts grain yield. Are you placed in the center of that crop growth zone, by the way, or are you way over next to the ground cover? Makes a huge difference. What are the herbicide program limitations that are occurring because of the ground cover that you have? This fifth one is the one that really, for me, was out of the blue. I didn't see it coming. Ground cover persistence, and you've heard me talk about that RHB, that Radix hybrid bulbosa. In many ways, it was looking to me like it was going to be the preferred approach over Kentucky bluegrass, at least early stage. And we've found some struggles with its persistence just in this last year, our 3rd or 4th year of having it there, that has made us have to really think carefully about how we're managing that and whether we still believe that RHB is the early way to go. And this one, which I've mentioned to you before. And we have been, essentially since day one, been working with RMA to keep them appraised of this vision, aware of this vision. Yeah. So I've said this already, but Kentucky bluegrass and Radix hybrid bulbosa are our 2 leading ground cover candidates. You can all read these comments under each one. What's interesting then is to sort of interlace those primary risk factors with these 2 things, and this is sort of a visual way of thinking about it. That what we would say right now is that on the establishment, Kentucky bluegrass is a high risk, and the RHB is a medium-low risk. On suppression, KBG is medium and RHB is low, and so on. Again, I won't insult you by reading this, but this comes through failure. It's really valuable for us to be able to understand this and communicate this to people who are thinking about doing this. Perennial ground cover is fundamentally a balancing act where you have Kentucky bluegrass is somewhat a little maybe too competitive, thick, creeping, hard to suppress. RHB is a little bit on the other side. It's a little fragile and sparse and static and easy to kill. Our breeder's dream or breeder's perfection is something that sits right between those 2, but that's not what we have. Because in a way we're not at a stable equilibrium, we use management to keep RHB alive, if you will, minimum suppression, gentle strip tillage, and a different management to keep the KBG in check. That's the way we think of this. I'm going to do a little side note here because I promised to talk to you about the Valley of Death, and I need to talk to you about technology readiness levels first. They were developed by NASA 50 plus years ago as a way of assessing the maturity of a particular technology. They've been used in other settings. My friend Peter Keeling developed one for biorenewable chemicals, bio-based products back in 2014. And NEFA defined a cropping system, TRL, back in 2018 to assess progress in the development of a new technology and communicate the maturity level. Okay? Using NEFA's definition, we estimate PGC to be around a TRL of 4. Experimental testing is what they call that, where we're conducting field trials or other technology performance experiments to determine the potential yield, product quality, operational efficiency, and so on. Okay, I think that's a pretty reasonable way of describing that. And this is fantastic. We've moved a long way from a paper that Ken and his graduate students wrote almost 15 years ago, which was really TRL1 proof of concept. So we're going to pat ourselves on the back, and then we're going to take a deep breath, because when you're at a TRL of 4, you are at a place where you're leaving the realm where that nice academic level federal funding is available. That tends to bleed off when you get there. And somewhere out here at like 7, you start getting industries sufficiently interested that you have access to their funding. And by the way, your costs are sort of doing something like this the whole time. And people call the 4 to 7 range the Valley of Death. So we're at the gateway to the Valley of Death, and boy, am I glad I get to talk to Brandon about approaches to getting around this, and Sarah and Dan and all the other great people on this project, because it makes you take a deep breath sometimes. At TRL-7, for example, we might anticipate 10,000 acres across dozens of cooperating farms trialing low-risk instances of perennial ground cover. Who's paying for that? Who's helping de-risk that? So how are we trying to do this? We are trying to get, and I'm not going to lie to you, I thought we were going to do something this past 6 months that I didn't do. Some of the other hiccups with funding and whatnot, and some of the concerns with longevity that I hadn't seen coming caused me to take my foot off the gas a little bit. But I think summer of 2026 we'll be doing more of this, trying to get some of our best current systems into trials with 10 to 20 farms to accumulate acre years of data to feed into the RMA process of determining whether we have an insurable practice or not. Continuing the research to address the more fundamental research that we at the universities are good at doing and comfortable doing, and continuing to pursue other additional avenues of funding. That's basically what we're doing. Now, I am going to take a deep breath and come over here. I'm not looking at the questions in the chat, and I apologize. I will do that later. I am keeping an eye on the time, and I'm going to turn this over to Brandon and mute myself. And Brandon, you just yell next slide, and we'll go.
Thanks, Raj. Well, this is just a quick diagram, I think, of an outcome that we're shooting for in RegenPGC, and maybe getting to sort of building a network of research and our sort of scale model for how that research eventually makes it out into the world. And Raj and I were talking about today that he thinks the scale's flipped around here, but my original concept was that we've done a lot of what we might call PGC discovery research on the project, where we're testing lots of things in greenhouses, in growth chambers, in breeding plots, at research stations. And so the scale means that we're collecting lots and lots of data points at this sort of discovery level. And as we discover and learn more, we move up in levels, and the total number of data points might go down because we're going to, maybe small plot studies at research stations, or eventually to on-farm trials where the number of data points is less, but the learning has moved from discovery kind of up that sort of technology readiness ladder that Raj was mentioning. So I've been very excited to think through our data management systems and the networks that we've been developing and how it kind of fits into this model. Go ahead, Raj. I'm going to talk to you a little bit about my experiences and what we've been trying to do kind of on farm and at larger scales the last few years. One of the things that became obvious to me pretty quickly from Nebraska and Kansas is that strip till is kind of a core component for how we manage the crop zone where we plant the corn and soybeans right now, but ultimately we have to develop systems to be able to create crop zones in places where strip tillage isn't going to be possible. And that happens in, for example, northwest Iowa, northeast Nebraska, where we have really, really hilly areas where terraces are common. And so we've been looking at developing no-till systems, for example, this picture on the left is we mounted and built hoods with on the back of this planter where we can spray Roundup kind of right over the row, right as we're planting our corn or soybeans to knock the ground cover back. So that's one option. If you want to move to the next slide, Raj, I'll talk a little bit about RHB, which potentially we can no-till into RHB without doing any sort of banded herbicide application over the row or strip tillage. And this is a picture in Wamego, Kansas, like in 2021. This is when I first saw RHB at the Corteva Research Station. This is about May 25th. You can see there's corn just barely poking up in this picture where it was kind of no-till to here. But the RHB is completely brown already. It's dormant. It's a summer dormant perennial species that is pretty much brown like this from about the middle of May until early September. So really fits the how do we separate the competitive interactions piece that I mentioned earlier. Go ahead, Raj. These are two other RHB pictures. On the left is a picture of a field in Nebraska that I have that's under irrigation. So the carpet of green is all RHB. This is about the 5th or 6th of May, maybe. Um, I'm sitting in the sprayer here, ready to apply glufosinate to force it into dormancy a little bit sooner. Um, to get the corn planted. On the right, you can see this is the corn like in probably, I don't know if this is late July, early August, maybe. You can see the RHB residue there on the ground is completely brown. It's just barely starting to poke back up, which is what makes me think it's August. And yeah, so RHB has a really shallow rooting depth. And actually, after it goes dormant, it lives as a bulb in the ground and the roots completely die back over that summer period. And then the roots start to regrow again in September. So, rooting depth wise, maybe over the winter, the rooting depths or early spring are similar for KBG, but in general, KBG has a thicker rooting depth, thicker root mat in the top few inches of the soil. So, this is at harvest of RHB. So you can see on the right, there's RHB that's already come back and looks really, really good. On the left, you can see a lot of corn residue that's on top of the ground and has been one of the big challenges for figuring out how to maintain the persistence of both Kentucky bluegrass and RHB. So this is irrigated in Nebraska. So we typically see yields that are 240 to 270, even with the RHB. And so there's lots of leaves, lots of stems. And with the typical shredding heads on the combines that we have now, we create a mat that's 4 to 6 inches deep. And so it can smother the RHB just like leaves on your lawn from a tree would smother your grass over the winter. Go ahead, Raj. So this is Kentucky bluegrass. This is a field that has just been strip tilled to create a crop zone. So you can see we plant it with a drill. In this case, we've started to plug rows in the drill now, but this was my first time, and this is 2021, my first attempt at this, and so we've strip tilled and killed out basically one of every fourth row here to create an area to plant corn or soybeans. So this is it green in the spring, ready to be planted pretty soon. If you go to the next slide, Raj, this is a study that you can see where we've planted this already. And then on the left, you can see this is a kind of a control strip where we didn't apply any glufosinate or Liberty herbicide to the grass. So it's unsuppressed Kentucky bluegrass. On the right, you can see that the grass is already turning yellow. And this is what we mean by suppression. So the Liberty is a contact herbicide that is going to kill anything that's above the ground and turn it brown and hopefully reduce both the competitive effects of the plant rapidly using water and nutrients in the soil and also producing what we call the shade avoidance response, a sort of response that happens in corn when it sees a competitor based on light reflection. Go ahead, Raj. This is that picture of the suppressed Kentucky bluegrass about a month, maybe 3 weeks later. So you can see it's really, really brown now. We don't see very much Kentucky bluegrass at all. This was a little bit unfortunate. You can see that the corn got hailed on. So it doesn't look that great, but the grass looks well like we want it to look after a suppression event. Okay, next slide, Raj. This is the non-suppressed Kentucky bluegrass. You can see it's still green and growing next to the corn and competing with the corn. Go ahead, Raj. This is a month later. This is the suppressed Kentucky bluegrass starting to reemerge. You can see it looks thinner than the other areas, and that's probably okay. Still not really exerting a lot of competition in terms of water on the corn. Next slide, Raj. This is the same day, but under the unsuppressed part of the field, you can see there's a lot of grass. We haven't seen the water competition being a huge issue in Nebraska under the pivots, but you can imagine in Iowa in July, if you had a week or two without rain, that the grass would really be competing with the corn. This isn't a great picture, but this is the grass August 11th, I guess, with an ear corn. Go ahead, Raj. This is the 31st of August, and this is an interesting picture to me because you can see that the grass has started kind of going dormant. Kentucky bluegrass can go dormant under kind of hot, dry conditions. But you see the ears of corn here are pretty large and getting closer to senescence and maturity. And then here's the 21st of October when we're harvesting the field. You can see I had a row plugged in the planters. You can see that mistake here, but you can see a lot of the grass growing back really, really well in that little blank area. So, and then these are some results of work that I did on farm this year in Nebraska. This is a Kentucky bluegrass between rows of soybeans right at harvest, basically. These soybeans averaged, there was no yield difference, statistical difference here, but you can see that the Kentucky bluegrass did hurt the yield a little bit probably. And we were around 75, 76 bushels on both the control and the Kentucky bluegrass. This is the fall, so this is what the bluegrass is going to fill in the whole crop zone over the next few months in the fall here. Go ahead, Raj. And then this is this year's data for corn with Kentucky bluegrass. You can see that we did have a yield loss of about 15 or so bushels this year, 17 bushels maybe. So we averaged, around 210 versus just under 230 for corn on these on-farm trials. And that's typically what we've seen. With the RHB on-farm trials, we're not really seeing any differences, but with the Kentucky bluegrass, we're still, I think, struggling to reduce the competition to the extent that we should, especially in older fields. So the Kentucky bluegrass in this particular experiment was planted in 2021. So this is our fourth year of doing it. And by the fourth year, it's really formed a sod, fills the crop zone in really quickly and grows back really quickly in the spring based on when you strip till and apply the herbicide suppression. So I think that's my last slide. Go ahead, Raj.
Thanks, Brandon. We're getting some feedback, so I keep muting myself when I'm not talking. Yeah, so that's our story. We think, well, I'll riff for one more minute, and then we'll go straight to open Q&A. That I think this is an amazing vision for a novel conservation practice that for some farms, I don't pretend that it's for everybody, but I think for some farms it makes a lot of sense. I didn't include the slides on it, but one of the things that's come out of this recognition of how you can fail these systems is sort of the inverse, which is what are the qualities you need on a farm to have the highest chance of succeeding. So we have such a list, and it's something we're starting to use when we talk to people tomorrow. In fact, at the Integrated Crop Management conference down in Altoona, Dan Anderson and Sarah Lira and Brent Wilson, who's a former Corteva agronomist, and I will be presenting and talking some of these slides, but more focused on how you actually go about doing this than we did today. Anyway, I appreciate everybody's attention. I'm going to stop my screen share, I think, and just go to conversation with people.
Right, before you, could you bring your...
yeah, I should put the last slides on that you wanted. I apologize.
Okay. You're fine.
That's good.
All right, so before we get into questions...
Yeah, sorry.
I just want to thank you all for attending, and if you would like to watch this seminar in the future, or you want to go back and look at any of our recorded seminars, you can go to either this website or use this QR code. Okay, so we did have some questions come into the chat. Can you talk a bit about the need for stover removal with RHB?
I'll start and Brandon can correct it. The RHB fundamentally is a less aggressive plant, and we think that if you have high stover loading, so if you're in a production setting where you're at Iowa typical 190, 200, 240, that if you have the stover associated with that kind of grain yield, we're concerned that 3 years you might see some real reduction in your RHB stand. So stover removal, if you can do it, we think it greatly increases the appeal of RHB. If you don't have such high yields, maybe it's not as much of a concern. If you're drier, maybe it's not as much of a concern. I think that the highest risk, I think, is high traffic, high stover, wet-ish conditions. RHB does not like. It's Poa bulbosa is native to the Mediterranean, and yeah, I think it's reflected there. Brandon, you correct me.
Yeah, I would say so. In my experience, I've had more persistent RHB in fields where we've baled the residue and taken it off. And so I started noticing when we didn't do that, it really hurt the stand persistence quite a bit. And I think there's multiple reasons why that might happen. One of them I think that's really important is that RHB is a bulb and it's dormant the whole summer. And when it starts breaking dormancy, it's using carbohydrates in that bulb to grow. And so if you cover it up with a bunch of residue exactly when it's trying to grow, it's going to use the carbohydrate reserves and kind of kill itself before it can find sunlight and start doing photosynthesis to replenish those carbohydrate reserves. Whereas the Kentucky bluegrass is growing the whole summer long, growing more vigorously in the fall and building up, I think, some carbohydrates in its roots, which have a different sort of perenniality mechanism. So I think that's important. Second thing I've noticed persistence wise, how do we remove the stover? It's not very feasible to bale all the stover on all the corn on all the acres in Nebraska or Iowa. And so we've been trying to graze a lot in Nebraska, but I've been watching, especially this fall, we had a little bit wetter fall. The root system is really shallow right now in the RHB, and especially when I was grazing the end of October and early November, you could watch a cow grab a bite full of RHB and all the bulbs and a clump of soil would come out with it. And so I've been watching the cows kind of mess up fields that in that way also. So that's a key thing that we need to figure out is where can we grow RHB without it being a problem? Besides grazing it, what's a feasible way to deal with the residue? Yeah.
I should mention that I think I indicated that this awareness about the RHB persistence problem is pretty recent for us. And after the initial sort of despair phase, you kind of catch your breath and start thinking about ways around this. And there have been some interesting proposals. Dan Anderson had a nice little vision of maybe how you manage RHB to make sure you can get to 5 or 6 years. Because so the truth is, like, perennial ground cover. Well, I mean, things are always changing. Do we really think we're going to do this for the next 50 years? Probably not, right? But if you have something that has a planting cost somewhere between $50 and $100 per acre, and you can do that, let's call it $90 an acre, and you can do that for 6 years, that's a $15 per acre cover crops solution. And so there might be traction even if it's not truly perennial. I know you have another question, Kay. Sorry, go ahead.
Have you used white clover, or could white clover be used as the cover?
So I'm a clover breeder. That's my job. And this RegenPGC project, we've focused a lot on grasses. And in general, I think grasses have a lot more potential at scale than clovers do. One of the main limitations of clover right now is that Nebraska and Iowa both, if you think about what are the herbicide tolerant and resistant weeds that we have, they're broadleaves. And so we typically need to have a 2,4-D or a dicamba available to us. And so what we saw early on when we started trying to do on-farm trials with clovers and grasses is that the majority of our clovers, even if they got established well, we had a lot of broadleaf escaped weeds, and the main way that we could handle them was coming back and using dicamba and 2,4-D. And that's a pretty there's a reality now. I'm a young farmer. Like if you're going to rent ground, you can't have weed escapes. And so the grasses let us use that particular chemistry without any problems. The other thing, particularly about white clover, so my program's been breeding and using another species called curra clover. White clover is not as persistent, and so in a dry year it can go away and kind of never come back, and then you're left with fields where it's patchy, and you can imagine a grower having to make a decision about, is there some threshold where we come back and replant the field? When it's patchy, we're no longer getting the weed suppression that we need to be able to not use dicamba, 2,4-D, and other broadleaf herbicides. So I think there's some real challenges to using clovers compared to the grasses that we talked about today in terms of technology readiness level and scalability.
Is spring management of the grasses the same whether you're planting corn or soybean, or does management differ based on the crop you're planting?
Yeah, I would say that in general, there's not a lot of differences to me. In Nebraska, we're planting beans and corn earlier and earlier and earlier. So um, I think that maybe you have a little bit more, a little less risk with soybeans. They're gonna not respond to the competition with the corn as readily as the corn, and so maybe you can get by a little bit without managing the suppression as well. But in general, we're going to strip till for both. We're going to use glufosinate for both to turn the grass brown at the right time and move forward. So yeah, in general, they're the same. We haven't had any success, I think, planting beans with a drill on 15-inch rows. Everything that we've mostly done right now is in wider rows, 30-inch rows, where we're maintaining a crop zone where both those crops are getting planted.
I think that Dan's experiment that I showed earlier, that NERF experiment in the first year, was essentially soybean no-till into a green RHB, which worked. But again, I would use the term non-conforming. We're not shouting that from the rooftops that this is what we ought to be doing.
I have done that successfully also with corn. And the key is to plant late, right? So if we start planting our corn May 15th or our beans May 15th, the grass is going dormant and you kind of escape that period of competition. But if you're going to plant April 10th, April 15th, you have a whole month of competition with that grass that the corn can't handle. The beans maybe can handle a little bit better, but the corn cannot. So.
Now, you mentioned that you had RU participants who were future teachers. What did you focus on for your interactions with those RU participants?
Well, that's interesting. I think that we did a couple of things. We always gave those people as a group an onboarding to the project done by a person done in a way to bring it to the level of somebody who doesn't have a background in agronomy. Okay? And then we instructed the graduate students, who honestly in general are the day-to-day mentors. We mentored them to ensure that they were attending to those basic questions and not making assumptions about what people knew. And I feel like we've done it for 3-4 summers with surprisingly good results. But you have to be ready to accept that you're not getting. I see Gabe Johnson here, who was an undergraduate with us. And I mean, if you had Gabe as an RU, you're going to operate differently than if you have somebody who's coming like we did in our lab. Dan and I had a person who had done 1 year undergraduate at a teacher's ed program at a small institution in Iowa, right? That person has a different background, but honestly, the value added that you can do for a person like that in showing them how we think about problems, what science actually is just, it's phenomenal, and I recommend it. Honestly, I had my fingers, I directed REUs that handled a total of 220 students from 2009 to 2019 here. And those were primarily students, chemical engineers, ag engineers, et cetera, the standard fare. And we worked hard to onboard those students and give them good experiences. But I think the impact that you can make teaching teachers about science, it's profound.
I think we'll do one final question. Rooting depth. What are differences between Kentucky bluegrass and RHB?
Yeah, so the RHB's rooting depth, I can't tell you exactly the total potential. It might go as deep as the Kentucky bluegrass during kind of the peak growth periods of the year, but the roots die almost completely back to a bulb as it goes dormant. So there's a 5 month chunk of the year where the depth is basically it's gone. There's little bulbs in the soil. Kentucky bluegrass makes a really, really thick mat of roots in the top kind of 4 to 6 inches. And I would say uses almost probably all the water and nutrients in that top 4 to 6 inches. And so that's one of the reasons we chose Kentucky bluegrass over other species. You can like Kernza that Raj mentioned, that has really, really deep roots. We have shallow rooted plants where imagining the corn and beans can use the water nutrients further down the soil. But I would say, yeah, Kentucky bluegrass definitely has much more root biomass. It's also rhizomatous, so it has roots that are spreading back into the crop zone, whereas RHB is a single bulb and doesn't have a spreading rooting function. No rhizomes or stolons.
Well, with that, we are at time. So I want to thank our speakers again for their presentation. This is wonderful. And thank you all for attending today.
Thank you so much.